So we're going to talk about the mechanics of classes. What actually happens inside the computer as it's executing object-oriented code, as it's using classes to instantiate objects and then calling methods on those objects and so on. So I have here a relatively straightforward 33-line program written in Java. I have a rectangle class, and a rectangle has a height and a width, which are represented by integer variables. It has a parameterized constructor for initializing those variables, and it can get the area, which just returns the height times the width, and it can draw itself. So a rectangle of a given height and a given width will draw itself as a pattern of stars or asterisks with that many rows and that many columns. And then I have a basic driver class, which just contains my main method, in which I'm instantiating a couple of rectangles using the parameterized constructor, and then having those rectangles draw themselves. So let's see what happens when we actually compile and run this code. First thing that's going to happen is the rectangle class gets created. And so we've got this blueprint for building rectangle objects, each of which will have its own integer for a height, an integer for a width, its ability to get the area, and its ability to draw itself. Then, of course, we have the driver class that has to be created as well, and it stores the main method, which is what gets executed by the operating system when we run this program. And so at this point, we're about ready to start executing this program, and we ask the operating system of a computer to run a program for us. And you may have noticed that the main method of a Java program does take an argument called args. And the data type of that argument is a string array. It's just a collection of strings. What this is really about is you can start a program from the command line, and when you do that, you just name the program. But you can also pass arguments to that program by putting them after the name of the program, separated by spaces on the command line. And if you were to do that, then those arguments are going to get stored in this array, this collection of strings. And then your program could look at those arguments and maybe make some decisions about what it should do. But the array of strings gets created by the operating system and stored in the computer. And that's what's used to initialize that parameter variable for the main method. So as the operating system is calling this main method, of course, a stack frame gets created. The return point is noted, and in this case, it's kind of interesting because the return point is not inside of this program. It's not another line in this program. It's the operating system that called the main method. So when the main method returns, it's returning to the operating system, and that's terminating the program. So we just mark that. And then the parameter is passed, the argument is passed. In this case, it's this string array, which lives somewhere in memory. And we'll just assume in this case that no parameters, no arguments were passed into the main method by the operating system, but it still has this argument called args. So the next thing that happens in the stack frame is the local variables are created, which includes the parameters and the two rectangle variables A and B, and they're initialized. The parameter is initialized with the argument value, which is just a reference to this string array in memory, and the two rectangle variables are initialized to null, meaning they don't currently refer to anything. And now we're ready to start executing this method. So on line 26 here, it's a relatively simple looking line, but there's really a lot going on. We've got a rectangle variable. We're about to instantiate a rectangle object, calling the parameterized constructor, and then assigning the created rectangle to the variable A. So let's step through that and see what actually happens here. First thing that happens is we're going to new up or instantiate a rectangle. This is going to create a rectangle object in memory using the rectangle class as its blueprint or its template, which is really just a height variable and a width variable, which are initialized to 1 according to the class. And then once that rectangle is instantiated in memory, we're going to call the parameterized constructor. That's a method, and so a stack frame is created. The return point is noted. We're calling that constructor from line 26 in main. And then the arguments are passed into the stack frame. the local variables are created. And remember, when we're dealing with a class, an object of class that's been instantiated, we have this special reference variable called this that always exists inside the method. And it's a local variable. And it gets initialized with the object on which the method is being called. So in this case, we're initializing or constructing this rectangle object. And so that's what gets assigned to the this variable in this context. And so it's just a reference to this rectangle in memory that just got instantiated. And then, of course, the argument values are assigned to the parameter variables. And now we can execute this method's body. And so this is going to take the value stored in height and store it in this, which is reference to this rectangle height variable. So we're going to take this 3 and store it here. And then we're going to take the value stored in width and we're going to store it in this width. So we're going to store that 5 here. And that's the end of this parameterized constructor. When the method returns, the stack frame is cleaned up, local variables are destroyed. We note the return point. We're going to return to line 26 from where we were called. And the stack frame is removed. We return to the return point. And then that function call to the parameterized constructor has finished. And then it's important to know that a new statement, when we instantiate an object, then that statement, that expression evaluates to that object. So this becomes a reference to this rectangle, which means that we're going to assign a reference to this rectangle to the variable a. And so at this point, by the time line 26 has finished executing, we've instantiated a rectangle. We've called its default constructor to initialize its variables. And we've captured that reference and stored it in a local variable. And we're going to do the same thing here on line 27. We're going to instantiate a new rectangle using the initialization values for its height and its width. And then we're going to call its parameterized constructor, creates a stack frame, notes the return point to line 27, passes in the arguments, creates the local variables, and assigns values to the local variables. Remember, this local variable is going to be assigned a reference to the object. And now we're ready to start executing the body of this parameterized constructor. Same thing is going to happen as before. We're going to assign the value of height to this height. So we're going to be storing a 2 here. And then on the next line, we're going to assign width to this width. So we're going to be storing a 4 here. And that finishes this parameterized constructor. The constructor function or method returns. The stack frame is cleaned up. Local variables are destroyed. We note the return point. We're going to be returning to line 27. The stack frame is removed, and we return to line 27. Remember that this new statement, when we instantiate an object, that expression evaluates to a reference to that object, and we're assigning a copy of that reference to our local variable b. And so at this point, we have a main method, which is still executing, which has 3 variables. A and b are rectangle references. A is a reference to the first rectangle that we instantiated, and B is a reference to the second rectangle that we instantiated. And so now we're about to execute line 29. We're going to ask rectangle A to draw itself. So we're going to be calling the draw method on rectangle A. What does that look like? Well, when you call a method, a stack frame is created. The return point is noted. We're calling this method from line 29. Any arguments would be passed. There are none in this case, so local variables are created. And inside here, we have a variable called row, and a variable called call, and then there's always the variable called this. And then those variables are initialized. The this variable is initialized to the object on which the method was called. This method draw was called on the object A, which is a reference to this rectangle object. And so the this reference variable in this stack frame is initialized to that object. And now we're ready to start executing the body of this draw method. What we have here is a nested set of loops, a for loop that's going to loop from 0 to the height, and a nested for loop for each of those. It's going to loop from 0 to the width. So this is going to go through each row that we have to print and each column in each row. And for each column in each row, we're going to print a star. And at the end of that row, we'll print a new line, and that will allow us to print the next row. So let's see how this works. We'll step through this a few times just to get a sense for what's going on. We're going to initialize the row variable to 0. We're going to test this condition. Is row less than this height? Well, this is this rectangle, and its height is 3. Row is indeed less than 3. 0 is less than 3. So we're going to enter the body of this for loop, which causes us to initialize the call value to 0. We test this condition. Is call less than this width? Yes. 0 is less than 5. So we're going to enter the body of this loop, which has us print an asterisk. When we hit the bottom of a for loop, we execute the incrementer. And when we execute the incrementer, we test the condition again. And we look at the value of call, and we compare it to this width. It's still less than. So we execute the body of the loop again. Another star, increment, test, another star, increment, test, another star, increment, test, one more star. At this point, we increment call, and the new value is 5. We test the condition. Is the value of call less than this width? 5 is not less than 5, so this condition is false. So we exit the loop. And the next instruction after the loop is to print a new line. That just brings us to the next line. And that is the bottom of the outer for loop. And just like when we hit the bottom of the inner for loop, we go up and we increment. So we increment row to 1, and we test the condition. If row, which is 1, is less than this height, 1 is less than 3, then we enter the body of the loop. And we execute that inner loop again, which is, of course, going to loop from 0 to the width. And for each of those, it's going to print a star. So it prints 5 more stars, at which point the value of call becomes 5. This condition becomes false because 5 is not less than 5. We exit the loop. We print a new line, which is the bottom of the outer loop. So we go back up and we increment the row variable to 2. Test that condition. 2 is less than this height. And we enter that inner loop again. And again, we end up printing 5 more asterisks. When call is incremented to 5, this condition becomes false because 5 is no longer less than 5. That finishes that inner loop. We print a space. That takes us to the bottom of the outer loop. We go back up. We increment the row. Row is now 3. We test this condition. Is row less than this height? No. So we exit that outer loop. That's the end of this draw method. The method returns. We clean up the stack frame by removing the local variables. We note the return point. We're going to be returning to line 29. We remove the stack frame and we return control to line 29. And that call to a.draw is complete. The next line in main simply outputs a blank new line, and then we call this draw method again, in this case, on the object referred to by local variable b. So again, we call the draw method, a stack frame is created, the return point is noted, line 31 in this case. If there were any arguments, they would be passed. There are none, so we create the local variables, one for row, one for column, and always one for the this variable. Those are initialized. The this variable is always going to be initialized to the object referred to by the variable on the left-hand side of the dot operator. So b refers to this rectangle object, and so that's what the value of the variable this is initialized to. Another reference. Notice that it's possible to have multiple variables that refer to the same object. So I've got two variables here. I've got a variable named b, and I've got a variable named this, and they both revert to this one rectangle object. And at this point, we can start executing this again. And of course, it's going to go through its double nested looping structure, and in this case, output a series of two rows of 4 columns each. And then that finishes. We clean up that stack frame, return to line 31, and this is the end of the main method. And when the main method returns, the same thing happens. We clean up the stack frame, all of the local variables are destroyed. We note the return point. In this case, we're going to return to the operating system. And when we do return to the operating system, the program terminates, and the operating system cleans up all of the memory that was being used by that program, and it's now free to be used by another program.